Alright, how are you today? I am going to make a video that shows how to use TRS-80 extended color basic function called get input. So this is going to show you, if you don't know how to use them, show you how to use get input. Okay, so we're going to get started here, and I'm going to set this up for P mode 1, which is low res color, and you get 4 pages. We're not going to be using pages, but you do get 4 pages. Well, actually you get 2, but if you use P clear, you'll get 4. So we have first P mode, then we have to pick our color set, and I like to use color set 0, which is green, yellow, blue, and red. So the 1 tells you that you're using a graphics screen. Otherwise, the 0 would be a text screen. You would have no reason to put a 0 there because you start off in text mode. But if you did put a 0 there, it would be text mode. 0 or 1 are your only options. There's 8 colors with this computer. There's also black, but you don't get to use black unless you use black and white, which is a different P mode. So yeah, there's 8 colors and then there's black. So we're using green, yellow, blue, and red. So now what we want to do is you have to clear the graphic screen. If you don't use PCLS, it would be like not using CLS on a text screen, and you'll get all kinds of garbage all over the screen. So it's basically clearing the screen memory. You have to use that. You have to have these 3 lines every time you want to use the graphic screen, which is most of the time. So make sure you include these 3 lines. So our next line is going to be a Rem line. We're going to be making a spider today. So I'm going to start off with making the spider. And this is very simple. I'm going to put it up in the upper left hand corner here, which is the good way to do it. And it's going to be a 5x5 figure, and I'm going to do it the fastest way possible. So we are going to select a color. We're going to make this spider red with yellow eyes. See how that works out. So we have to pick our color. Color 4 is red. And then we go for a line, and we're going to go 0. We're going to go 0, 0 to, it's going to be a short line, 0, 0 to 0, 2. That's going to be 1 leg. Then we're going to make a second line, and it's going to be 8, 8, 0 to 8, 2. That's the second leg. Now we're going to put 100, go to 100. We're going to check our work here. And Centex error in 6. Yeah, I'm doing good. Edit 6. So the problem here is that you have to P-set this. P-set. Every time you use a line statement, you have to follow it by comma P-set, which sets the line. And see, now we have our 2 legs up here. Those are his top 2 legs. Now we're going to make his bottom 2 legs. uh, 8. So line, there's as long as you don't change the color, it stays the same color until you change it again. So his third leg is going to be 0, 6 to 08 piece set. And the last leg on this guy here is going to be 8. Should be 8, 6 to 8 piece set. And we're going to run this and check it. Okay, so now he has 4 legs. Now we're going to make the body. And we could make it blue and with yellow eyes, or we can keep the body red. I don't know what would be better, so let's try making the body blue and see what it looks like. If it doesn't look good, I can always change it back. So for this, we just need to cross 2 lines, basically. Now, these are pixelated characters like you would find on Atari, basically, or early video games, but they still work really well. You can do a lot if you learn how to draw them. It's a very even Nintendo, the first NES, they were all pixelated characters. It was just a better technology. But if you look carefully, they're all very pixelated. So this would be one step behind that, I guess, depending on your skill level. So here we go. We're going to cross 2 lines here. It's going to be 4, 2 to 4 to 4, 6 piece set. And our last line here, we're going to cross 2, 4 to 6, 4 piece set. Okay, so see how those 2 lines crossed? He has 4 red legs and a blue body. Now we have to put his eyes in, and he'll be all done. And it's just a small 5x5 character. And what I mean by 5x5 is literally 5 pixels by 5 pixels square. So it would be a 5x5 square, however you want to do it, whatever way you want to think about it. If you think about geometry when you were in school, you know what a 5x5 square looks like. You know, same thing here. We're not using, now 5x5 would be 25 if you multiplied it, so you could have up to 25 pixels in a 5x5 space, but we're not using the entire space. We're using a 5x5 perimeter, but we're not using all 25 pixels because we don't need them, but you could have up to 25 pixels. Now for his eyes, we can't use line, we have to use piece set. And what piece set does is it sets a single pixel. A line sets, just like in geometry, it's connecting dots. So if whenever you use line, you're connecting pixels, dots, whatever, and you end up with a line. Alright, so our first eye is going to be located at 2, 6, and when you use piece set, the color is included in the bracket. When you're using the line statement, the color statement is separate, like this here. But piece set, you have your X and Y coordinate and your color. Now with the line, what you're doing is you're using an X and Y coordinate to another X and Y coordinate, And then when you put the pset command in at the end, the computer automatically connects them. You can do this diagonally. It doesn't have to be a straight line, but anyway, so we're gonna set his next I 0 to at 6, and the color is going to be 2 because I decided on yellow. Now if you look very carefully, this guy has 2 bright yellow eyes, almost like a flashlight beam coming at you. And this is very similar to Galaga. It reminds me of characters from Galaga or Galaxian. It's basically what they used. Now, just for our own purposes here, we are going to edit line 3, and we're going to try to make this show up a little bit better. Now, the problem is we used all of the colors except for green, so I can't make it show up any better unless I change some of the colors. So I think I'm going to leave this the way it is for right now, but I'm being very bland here and very basic. I could have a blue background with a whole totally different colored spider. I mean, you can really do it up, but this is just for educational purposes right now, so I'm not getting into any big details. I mean, this computer is pretty hard to program, so once you get going on something, you basically have to finish it, and you can't make a lot of changes. It's very hard to edit lines. This computer is difficult to program for a lot of reasons, so I'm just going to leave it there. And now what we're going to do is we're going to make a new Rem line. You always want to make Rem lines so you know where you are. These programs get very long. They have to be printed out from time to time so you can go over them, because the lists just become too long. And that's why they had printers for these computers. Alright, so it was less word processing and more for programming in this era in 1982, but whatever. So now what we want to do is we want to get the spider, and basically it's the way it sounds. We're going to make a carbon copy of this spider, and we're going to relocate it somewhere else on the graphics screen, and that's what get input is for. So first we have to give it memory space somewhere in the video memory. So we're going to call our dimension A, and we're going to give it a very small amount of space. That's all you need. And what happens is the computer will store it in dimension A, and you can recall it anytime you want. It's very convenient. So the next thing that we have to do here is we have to find our borders. Very important. And we're going to do this in yellow. So I'm going to color 2. And after I do this, these lines are going to be discarded. This step here is very important, and the only reason you do it is to make sure you're using the right borders. 0, 2, 4, 6, 8 are our borders. We have 0 to 8 on the x coordinate and 0 to 8 on the y coordinate. So we're going to start in the upper right hand corner at 0, 0. And we are going to end in the lower right hand corner at 8, 8. We're going to p-set that. However, we're going to do comma B. And what comma B does is it, instead of making a line from, this would actually be a diagonal, perfect diagonal line from this point to this point. But what you do is you use the uppermost left hand, the point in the top left hand corner, it's always going to be a square when you use get input. Okay, it stores it in a square. It can be a rectangle. A rectangle is still a square. It doesn't have to be perfectly square, but it does have to be square. It does have to be square, okay? Can't be a circle or anything else. So we start in our upper left hand corner, and then we take our lower right hand corner coordinate, those 2 points, and then we p-set that and we follow it with B. And as you can see, it's created a yellow box around just the perimeter of the spider. And it covers up some of the detail, but you want a perfect box around your figure. Okay, now we know it's correct. This box is what the computer is going to put into that array. Only what's in this box, including the border. Now, some people might not know, and they might make it too big, but literally all you need is, I mean, it doesn't matter if you make it a little bigger. If you want to do it that way, that's also fine. You'd be able to see your image. If you want to see your image, then just don't cover up all of it. Cover up just the outside border. But the way I do it is I cover up the border itself. So what I mean here is I'm going to edit 17, and I actually don't even need to do that. I'm going to edit 18, and I'm going to rem this out. And when I run it, the spider comes back because the yellow was covering up a lot of this spider here. But now that is only for locational purposes. So once you find this value here, you can get rid of this line. But you want to leave it there though. You just rem it out, and the computer will bypass that line. Anytime you have a rem, the computer just ignores it. And we're gonna do that for 17 too. It's not necessary, but just so that we stay at a good pace here. So now we find the information that we need. Now we can put it into our array, our dimension A. So we're going to type get 0, 0, 2, 8, 8. Now I'm deliberately going to make an error here because this is not listed in the book. It's something that I had to find out for myself. But I'm going to show you. Now, the spider is listed in this box here. So what you do is you copy it. Once you get that information, you copy it into a get statement. And then you use your array next, which is array A. And then you follow it by a G. Now, there's conflicting information in Extended Color Basic. Getting started with Extended Color Basic has some errors in that book. Okay, I found plenty of problems in there that they don't address, and this is one of the big ones here. Now it tells you you don't need G, you do need G, you might need G, you need G. If you don't use G, you might as well forget it. It won't work. It will give you problems. It won't display the picture right. And there's also a big problem with how the coordinates are taken. They say all you need is a box around just the contents. But in reality, you have to add 2 to whatever the second x coordinate is. If you do that, you're safe. If you don't do that, your whole picture, part of the picture will be corrupted. So this is very important. Now we're going to run this, and it has no effect, no visual effect. Okay, but now we're going to do the next part, and we're going to put the spider. And what this means is we're going to put him somewhere else. He's not just going to appear up in that left-hand corner. He's going to appear somewhere else. And I'm going to put him at 100, 102, 108, 108, comma, the array p set. Now let's see what happens when I run that. There he is, bang, right in the middle of the screen. So he went from here to here. Now I'm going to list this program, and I actually just discovered something. I guess I was wrong here. You don't have to add 2. I was under the impression that you did, and that's what I've always done. And this is a reason that I wanted to make this video, to see, now does that look blue to you right there? It looks to me like part of him is blue. If I'm not mistaken, it's really hard to see, but it looks like his leg is blue. And it is. And I think this is the point that I was trying to make. There's a little bit of a corruption in this picture. So to correct it, I am going to edit line 19, which is the get statement. And I'm going to change 8 to 10. And then I'm going to do the same thing on line 21. I'm going to change 108 to 110. And we're going to run this again. And now his leg is red. So it's not a fallacy, okay? You have to add 2 to the second x coordinate. I don't know why. If you don't do it, you're going to get a corruption of this right side, this last row of pixels. I don't know why. Sometimes part of it isn't there. Sometimes it's corrupted, like it was blue. It wasn't supposed to be blue. So it is a real thing here. And that's it. That's how you use get and put. It's if you practice with it, you can do all sorts of things. I could change this program a little bit. I don't want the video going too long, okay? But let's just, for fun, we're gonna renumber this. We're gonna renumber this, and we're gonna make some space in here. And we're going to list this over. Okay. And we are going to play around with this a little bit. I'm not sure exactly what I'm going to do here. Alright, we'll do this. For x equals 0 to 250. I'm not going to go too far. We'll go 0 to 254. Step 8, maybe. I can always change this if it comes up with an error. That's basically all I need to do here to make an animation. And what we're going to do is we just need the x coordinate, and we're going to edit line 40. We're going to put plus x. We don't need to do anything with the y coordinate because the spider is going to go from left to right now in an animation. So the first time, actually I need to change line 40. I need to change this to 0 to make this work. And then this to 10. And it will start at the left hand side of the screen and work its way over to the right. What we're going to need here is get rid of line 41, and we're going to have to put a little bit of a timer in here. So we're going to make 45 our timer. If you don't put a timer in here, it'll happen so fast you won't even see it. So we're going to put 4A. I don't think we used A. We used it in a dimension, so we're fine. You can have a variable A string variable A, and a dimension A, and they won't conflict. But you have to be careful not to cross them. For A equals 1 to, I don't know, we'll start off with 1 to 100. Next A, list this over again, list this over again, list this. Now we have our timer there, and after our timer goes off, we're going to PCLS it, which will clear the screen. And then 49, we want our next X. Next X. Let's see what we have so far. And there he goes, from left to right across the screen. Ding, 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 ding. Just like a video game or something. And that worked out pretty good. The only thing is, I might take 8 off of this, because, and I don't know if 246 divides by 8. 246 divided by 8, it doesn't come out even. 8 times, I don't know. It's too hard to do, but let's see if that changed anything. So it doesn't get cut off at the end. Yeah, it looks a little bit better. And then we can make it go back the other way. 50 for X equals, just go 246 to 0, step -8. 51, put I think it would be the same thing. Then we have to put another timer in here. 4A equals 1 to 100. Next A, and then 53 PCLS, 54 next X, and then to finish it off, 55 will go to 21. Now we should get an animation that goes back and forth. And there it is. It's going to go from left to right, and then from right to left in a continuous loop. And this is how you do very simple, small animations on a color computer 1 or 2. And that's all there is to it. Now you can connect this to a joystick, and you can get your movement here. Instead of just being an animation, a robotic animation like this, you could use your joystick function and you'd be able to control this thing with your joystick, and there's the beginning of a video game. And there's not very much to it. Just this list here, what I showed you. And before I go, I'm going to renumber this so I can tell you exactly how many lines that took. It took 33 lines of code. So with 33 lines of code, you can do this. And if you have any questions, just feel free to leave a comment. And of course, if I change the timer, I'll show you one last thing before I go here. If I change the timer to, say, 50, alright, both timers, it'll go faster. See how much faster that goes? Now it's bouncing around there, and looking pretty scary there, that spider. If you did this on the Y coordinate, he'd be going from top to bottom like this. But this is just an X coordinate. This is just left to right. Okay, so take care, thanks for watching, and I'll see you later.